Okay, for the YouTube channel, hi, my name is Carlo Zanchetta. I'm from the University of Padova, Italy, and with this presentation, I'm presenting the result of funded research that we developed. The research is related to OpenBIM-based green public procurement code checking, rule mapping, information delivery specifications, and Gherkin tests. The research was developed in partnership with Valeria Galleran, who is a researcher of the LIA group, and Thomas Krijnen, who is here with me. So I thank him for the collaboration and his presence here. So as I already stated in our previous presentations, our interest is mainly in trying to use what is available nowadays in terms both of data model and actual and current tools. So my presentation skips from the motivations in terms of problem statement and research questions, and then to define from those two aspects of the methodology. Then I would like to go a little more into the experimentation, which is mostly trying to check the robustness of IFC to support green public procurement policy information requirement, and then at the same time the robustness of IDS in order to validate what comes out from this translation. So, starting from the motivations, we started from three problems. Okay, the first problem was focused on the information requirement standardization. So, at this time, there are diverse approaches to trace environmental product declaration and green public procurement information requirements. In particular, to compare those information requirements with the common code checking procedures. So the problem is to standardize the EPD and GPP information requirements to overpass national or local approaches, because in the end it's a communitary goal, okay? And in particular, when we talk about the digital product passports, information requirements alignment is required, as demonstrated by the literature review. On the other hand, we have domain-specific information requirements that overpass the limits of IFC, because we all know, I think, from looking at the faces that I already know, we are all aware of the fact that IFC cannot reach the granularity and the peculiar aspects involved in, for example, environmental product declaration or green public procurement requirement and validation processes. And the problem is that nowadays all the policies are based on naming standards. If I call that item in this way, then it means that probably it has a certain amount of recycled materials. And this is not affordable if we want to standardize, because a naming standard is a local approach, and this is not good. So this is one problem, and the other problem is that typically we face proprietary attributes which are possible in IFC, but they are the opposite of standardization, and this is not good. And then the third aspect is that we should standardize the code checking procedures. So due to the GPP directive, the standardization and national codes alignment is necessary. So from this problem statement, it generates 3, then 4 research questions. The first research question is if IFC a standard robust enough to support a regulatory GPP requirements, validation procedures? Then second research question is bSDD a standard to solve dialects in a standardized way? And the third research question is, can a regulatory verification procedure be fully translated into IFC-based procedures? Given the fact that it's quite clear that this is not fully possible, the other question was which validation language best suits the EPD and GPP code checking approach. So to try to give a response to those questions, we split the process and the research in let's say 3 phases. On the first phase, which we call specification phase, we try to fully map the national law decree for general public procurement and try to detect each class, each attribute to define which could be the validation process in order to check if the project is compliant, okay? Then, again, in the first phase, to try to overpass the limits of IFC, we tested bSDD to pivot on natural attributes of independent, but let's say semi-standardized extension of the data model. Then in the second phase, called validation, the second phase assesses the maturity of IDS by determining the actual percentage of code checking procedures that are supported, which is limited. So the third phase, which is integration, it conveys the identification and selection of more efficient language to validate the procedures based on IFC models. So starting from the first phase, we tried to detect the levels of IFC compatibility. So the rationale was to determine the percentage of GPP specifications that could be recognized into IFC. Try to be a little more quick. So we split the whole scenario in 4 categories: full compatibility, partial, potential, which means that it is possible but is highly complex, and sometimes it's based on some subjectivity, not because of the culture and the mindset of the model author, but based on the requirements that are coming from the law, and not compliant. We focused, even if it was possible, on the potential, but we focused just on the full or partial. Okay, so the second problem and the challenge was the IFC extension to encompass the GPP and EPD information requirements. So the problem is that on one side we have IFC proprietary P set, which I personally totally dislike, because yeah, it's a good way to convey the information, but it means that we have to share a mindset, a rule, a BIM execution plan for the whole Europe, okay, and this is not possible. On the other hand, we checked bSDD plus classification reference, so it has a high level of standardization or semi-standardization and a high diffusion, while on the other hand, the proprietary set usage has no standardization. And on the extreme right side, we have the IFC standardized classes, for example, as we already mentioned, the cost item or labor resource, which are wonderful, but they have a very low implementation nowadays in the market. So we decided to focus on the usage of bSDD. So as you can see throughout this approach, we mapped the full law decree, and we generated a bSDD, which is called CAM classification. CAMS is the acronym for Criteri Ambientali Minimi, which is GPP for Italian context. Okay, and we published in order to use it with the current tools. Okay, so from this, other challenges were generated, and the problem was that if we pretend to the market to use this approach, we do have to convey a tool in which this classification is available, and current tools sometimes has a problem in classifying materials or documents. Something that came out of the mapping was the very huge usage of classes that are almost unknown, like IFC project, IFC site, IFC building, and IFC systems. Okay, most of the modeling authoring tool doesn't write IFC system or distribution system. So from that point, we started working on some patches, in particular IfcPatch, using the IfcOpenShell resource, and this is automatically lead us to considering that if a public authority wants to detect the correctness of models, then it has to run into a CDE. So the patches were published to validate the models into the CDE. And there we started analyzing the IDS. So we faced the IDS limits, basically the impossibility to work on logical conditions, the difficulty on working on IFC document reference, IFC material, and data aggregation to connect multiple values to collect the overall value. So this led us to the second phase, which is the validation. And here, to assess the maturity of IDS, we define what could be the process model. Okay, so firstly, the formal check and update of models. So the model author, the designer, submits the model, and there is a previous formal check, and then the patching of the model if something is missing in terms of material specification. And then second, the actual validation process, which is split into applicability to overcome the limits, the logical condition, the conditional logic of IDS. We orchestrated multiple processes. So first, applicability. The first IDS verifies the presence of the source element. So if a wall is load-bearing, then probably it will have some rules to follow. Then second, another rule of IDS checked the then condition. So it has a material, and this material has to have some recycled materials. And in the end, what instead we can call a blended validation, which means to integrate IDS with the IFC Gherkin validation. So the level 2 criterion validation exposes 3 different scenarios. One is IfcPatch plus IDS and script. One is just standard script, standard-centric, so just the patch with the IDS. And the other one is script-driven. Okay, so to be a little more into some technicalities, one of the problems was that a lot of tools cannot read or write material specification. So throughout this workaround and graph rewriting DSL, we were able to move into something that was, let me say, semantically consistent and accessible throughout the CDA. So starting from the IFC material resource, instead of working with the property single value, we moved to a classification reference that could be achieved throughout the bSDD. And this solved a lot of problems. So facing the third phase, okay, the problem was if IDS is not enough effective, as I can state in this table, what are we facing, what are we using? So we compared some possible scenarios, and in the end, based off on the different levels of understanding and diffusion to the market, portability and the effectiveness of the language, we focused on Gherkin, okay? And Gherkin helped us solving the problem because, first of all, it has a similar IFC structure on graph pattern building using entity and attribute selection. And then it has some specialistic predicates, involve the availability of Python modules to build, to encompass IFC schema. And then it's split on functional steps. So for example, here we have just one feature of the multiples. Okay, so the first lines are descriptive, then we have the selection set, and the last line is the validation itself. So very quickly to the results. 44% of the criteria cannot be fully implemented due to absence of operational complexity and specific entities. And in particular, the IFC material, which is the stepping stone of the GPP discipline, does not allow analytical definition. I'm concluding. So here I specify the exclusion criteria. Instead, based on bSDD. In bSDD, solely on IFC, only 8% of entities could be delivered. Throughout bSDD, we had full coverage. And instead, talking about IDS, it has a high dependency on model normalization and multi-layered validation framework needed. So on the whole 38 criteria composing the GPP regulation, 95% required the corrective support. 87% of GPP criteria needed a script Gherkin. Okay, so very quickly, we demonstrated that IFC plus bSDD is proven to fully support the GPP information requirement, while the IDS it's not so robust. Instead, with Gherkin, it could be a good approach for the actual market. Thank you for your attention, and I'm here if you have any questions.